This is a model of CYP51, a protein found in the pathogen that causes the fungal disease barley powdery mildew. What makes this particular fungal protein very significant is that if a strain of barley powdery mildew is to become resistant to a fungicide, it most likely will be because of a mutation in this gene.
Fungicides that used to be successful at controlling barley powdery mildew, particularly tebuconazole and triadimenol, are now failing to control.
Professor Oliver's team has been taking isolates from field samples of the fungus and exposing them to the various fungicides at different concentrations. Resistant isolates have their DNA sequenced and cross-checked against mutations known to have resistance to the DMI, also known as the triazole group.
Since that story was produced in September 2012, Richard Oliver's Western Australian-based team has been able to expand on its work. Isolates of the powdery mildew pathogen from eastern Australia have been compared to the mutant mildew found in the west. And that's where Richard picks up the story.
What we found is that isolates of the pathogen from WA have a different mutation from ones from South Australia and from Victoria, Tasmania and New South Wales. Those isolates from Eastern Australia do not have this new mutation, which means that they are still susceptible, still well controlled by products with tebuconazole in them, for example. But we would also say that the WA experience has shown that that's a risky situation.
Risky, according to Professor Oliver, because the continued exposure to this particular group of fungicides will eventually lead to the building of resistance in eastern Australia. Rotating the tebuconazole group with other fungicides, using mixtures and applying the lowest recommended rates will instead prolong their usefulness. The research goes on.
So this is where Botrytis has affected the chickpea pod.
Jenny Davidson is another scientist studying fungal pathogens.
There are millions and millions of spores out there in the crops. We're collecting hundreds, so we're only collecting a very small sample of what's out there. And of those hundreds, over 10 years, we've found one that is resistant. So it is a very small number at this stage that is resistant. But if the pressure is put on that population and lots of fungicide is put out, it will mean that that resistant type will have an opportunity to multiply up.
That one isolate of Botrytis cinerea, which was resistant to carbendazim and found in a South Australian chickpea crop, was enough to flag a warning about the emergence of fungicide resistance. And to avoid that possibility, pulse growers have been advised to strictly follow chemical label application rates.
The first thing growers should be doing is reading the label recommendations and understanding the regulations as to how many sprays of a particular ingredient that they can put out on a crop. And with things like carbendazim and prosimidone, it is only 2 sprays that they can put in a particular crop. So if they stick to that, then they will be able to control or reduce the level of fungicide resistance building up in their crops.
Jenny Davidson is also researching the timing of spray applications and says growers of any pulse crop need to be very strategic about when they put out fungicide sprays.
The first spray that goes out is before you even see the disease. We time that with crop growth stage. We know when the canopy closes over is the last opportunity to get fungicide down to the base of the plants. So we say to our growers, for faba beans and lentils in particular, always put out a fungicide spray at that point. So we have done a lot of effort to work out what is the best time to put out the sprays to get the maximum return and the maximum control of the disease. So that whole epidemiology and understanding how the disease works, how it performs under different weather conditions has been very crucial to getting those fungicide strategies understood.
Botrytis is a fungus that can survive long-term in the soil or on plant litter as sclerotes, non-fruiting structures. Under warm, wet conditions, the fungus activates and spores can spread rapidly, making crop monitoring an essential management strategy, according to Jenny Davidson.
It will infect the flowers and they will rot and fall off, and of course that means then there's no pods and no grain for the farmer to harvest. In faba beans and lentils, it also attacks the stems so that the whole plant will fall over and then the whole plant dies. So obviously then you get no grain from those plants that die off. And it can move very rapidly across a paddock. You'll see big patches dying out very, very quickly. So you can understand from a grower's perspective why they want to get those fungicides out and why they're really keen to make sure that this disease is under control. But in terms of getting their fungicides out, they have to get them out early before the disease is spread, because once it started spreading, they come in behind with a fungicide, they're not going to get the control they want, so they put out another fungicide, and it may well be they keep putting out fungicides. That means then you're putting the pathogen under pressure, and that's when you start running into potential resistance, fungicide-resistant problems.
In the lab, it's divide and multiply to build pathogen numbers. In the field, nature can do the job even faster and on a large scale.
A lot of the diseases we work with are wind-borne. They're spread around by the wind. The spores are produced by the fungi and then blown very long distance. So we're setting up some research where we have spore traps that suck the wind in and then they capture the spores on sticky tape. Then we assess the spores using our DNA lab here. It can quantify how many spores of different fungi are sitting on those tapes. So we set them up in different places around the state. We're looking at the impact of different weather conditions, whether it's rainfall, temperature, humidity, wind and all these sorts of things, and the impact that has on the spore dispersal and just where these different fungal spores are spreading around.
Understanding the climate's impact as well as a pathogen's development makes it possible to give growers even more strategies to reduce the risk of fungicide resistance emerging.
Because we know so much about the epidemiology of black spot, we know when the spores, those airborne spores, are being released from last year's stubble. And so we monitor that, and in many years those spores are released before the crop comes out of the ground. So the farmers can change their sowing date according to the timing of that spore release. Effectively then they can eliminate the risk of black spot in their field peas.
Black spot is Ascochyta blight, and North America's experience of this particular fungal pathogen provides another example of what not to do.
They've been using the strobilurins quite a lot, and our understanding is that they've put out many strobilurin applications in chickpeas, and as a result they're now finding that those strobilurins will not control the Ascochyta in chickpeas. So that's another warning sign for our industry, because we're starting to move towards registration of these particular fungicides in our pulse crops, and we need to be aware that we have to use them properly so that they can remain effective over a long period of time.
So how important is it to protect the efficacy of the fungicides that are in use?
It's very important, because we aren't sure just how many of these actives are going to be available to the industry in the future. There are a whole suite of different fungicides in the world, but these are becoming more and more restricted in their use, particularly in the European Union, and quite often we do follow the world regulations in that area, so we may find that less and less fungicides become available to the industry, so we need to protect what we've got.
When specialist farm consultant Jim Orson was in Australia last year to speak at GRDC Advisor Updates, he highlighted the concern in the UK over the European Union's regulations on farm chemical use.
So we don't know yet the real impact of some of this regulation in terms of pesticide availability, but estimates have been done, and it could mean that we'll lose a lot of useful pesticides to broadacre cropping. There's a list of 22 or 26, depending on what standard you look at, some of which can have important herbicides for grass weed control, pendimethalin, and also, more critically, very valuable fungicides. We use a lot of fungicides in Europe. We have a lot of fungal attack in cereals. They create huge yield increases or prevent huge yield losses, and some of those are actually on this list of which could be at risk. So we do really worry about that.
Back here in Australia, the outlook is positive. To support growers in managing future fungicide resistance risks, GRDC has invested in the Australian Centre for Nectrophic Fungal Pathogens at WA's Curtin University and supports projects undertaken by independent research company Calyx Australia and applied research organisation FAR Australia, the Foundation for Arable Research. Via these research providers, GRDC is also working in partnership with chemical manufacturers to deliver new fungicides with modes of action suitable for use in cereals and pulses, while also protecting the usefulness of current fungicides.